So this will be the last lesson in chapter 11, and we're going to look at one other type of line. We talked about this type of line in chapter 4 when we looked at data. It's called the line of best fit. The line of best fit, the way we kind of approached it before was kind of inexact. We kind of just said, okay, draw the line where it looks like it intersects the majority of the data. So like if I'm going right here, see how they drew that line through the majority of the dots? I kind of have an equal amount above as below, and that kind of determines the line. There is a process for finding an equation of the line of best fit, and that's what we're going to talk about here in this lesson. So the process is as follows, and this is an estimate. It's not exact, but it is more exact than we approached in the past. So the first thing you have to do, you have to take all your x values and find the mean of those x coordinates and the y coordinates. That gives you a point. The x mean and the y mean gives you a point that you can put on your graph, and it'll be amidst all the other data points. Then you're going to draw a line through that point that kind of also best fits all the rest of the data. So you're kind of doing the same process you did in chapter 4, but now you're making sure that line goes through that mean. So think about what the mean is doing. It's taking into account all of those points, all of those x coordinates and y coordinates, and it's representing all of them as a measure of central tendency. So that kind of gives you like a hub that all the other points are represented by. So that's why you make sure your line goes through that point and then represents the rest, kind of doing the same process, a little bit above, a couple dots above, a couple dots below, and then estimate the coordinates of another point on that line. Once you have those coordinates, you can find the equation because you find the slope, and then you can find the intercept, or you can do point slope form would be even easier, okay? Because once you know the slope, you already have a point. The point is this right here, right? And then, once you have all that, you've got your equation of the line already ready to go, okay? You can even get it into to y-intercept form, and that would make it a little bit easier to work with. From that, you can make lots of predictions, okay? Because once you have a y equals, then you can just plug whatever value you want in for x. And you'll be asked to do that in some of these problems here. So once you know this process, it's a little bit easier to do the application part. So let's go ahead and look at what this process looks like. Okay, so here I've got a bunch of data values, okay? A bunch of x values and y values. So the first thing I'm going to do is I'm going to find the mean of all the x values and y values. So I'm going to do 2 plus 4 plus 5 plus 1 plus 3 plus 8 plus 6 plus 7. And there are 8 values there. Okay, so if you add all that up, divide by 8, what you get for your for this is 4.5, and that's that x sub m, or the mean of the x coordinates. For the y coordinates, we've got 4 plus 8 plus 7 plus 3 plus 4 plus 8 plus 5 plus 9, all divided by 8 once again, and you get 6 for that, and that's the y value. So the mean point there of the data, that's kind of the hub that I was talking about, is 4.5, 6. Okay? Now, I've kind of jumped ahead, and so what you would need to do next, you would need to draw your graph, XY axis, right? You need to put all the dots in there, okay? Let's see if I can separate this. There we go. Okay, and I've jumped ahead and I've already graphed this. Okay, so when you're done graphing, it looks like this. And the other thing I've done is I've drawn a line here that goes through all these data values. Notice how we have 3 below, 1, 2, 3, and 3 above. I've gone through a couple other ones here. Okay, so there's that, and I've gone through 4.5, 6. So I've gone through this point here. Now the next thing, okay, so this is x sub m, y sub m. The next thing is to get another point on this line that represents the data. Okay, so another point from this would be like, say, see I've got right here, this line goes through like this point right here. Change colors on you here. That's at like 7, 8. Okay, see how that goes to that point here. So I'm going to use 4.5, 6, and I'm going to use 7, 8. Now, to get this line, to get the equation of this line, okay, first thing I need is I need to find the slope. So to find the slope, these numbers are a little bit bigger, so I'll call this a 0.2 and this 0.1. So remember, it's y2 minus y1, x2 minus x1, and that's 2 over 2.5, and that equals 0.8. So my slope is 0.8. So putting this into point slope form, I'm going to use, for x1, y1, I'm going to use this, my hub. We'll always be working off of that because that represents all of the data values. 7, 8 doesn't necessarily represent all the data values. This one does. So I'm going to go and do y minus 6 equals 0.8 times x minus 4.5. Now, to get this into y-intercept form, again, because that's a little bit more useful to work with making predictions and things like that, what I'm going to do, let me resize this a little bit. What I'm going to do is I'm going to distribute this 0.8. So I have y minus 6 equals 0.8x minus 4.5 times 0.8 is 3.6. And then all I have to do to get y by itself, to get it in slope-intercept form, I just have to add 6 to both sides. So y equals 0.8x plus 2.4. And there is an estimate of the equation of my line. So if I want to say, okay, what if x is 4? Okay, then what's y? What's the best option for y if x is 4 for this data set? Well, I would do 4 times 0.8, that's 3.2. 3.2 plus 2.4 is 5.6. So 4 and 5.6 would be another point on this line that I could get from the data. So in that way, we could kind of predict where other data values are that haven't been collected in this chart. I could figure out what other points were within this data. I could figure out what other points are out past this data. So you're gonna see some of that in the application portion. So go ahead and try some of that. Let me know if you have any questions.